Hi, welcome back. In this video, let me solve questions based on power rule, composite functions and trigonometric functions. Good. I shall solve all the questions which are based in NCERT 12th class math book, CBSE book. So let me solve this 5.2 exercise which is majorly based on these power rules, composite functions and derivative of trigonometric functions. Let me start with the first question. See the first question. Sine of x square plus 5. So, first question is sine of x square plus 5. How can I do differentiation of this? Differentiation of sine of x square plus 5 with respect to x. It is a composite function. So derivative of sine function is cos, so it becomes cos of x square plus 5 into derivative of x square plus 5. So that is cos of x square plus 5 into derivative of x square plus 5 would be derivative of x square plus derivative of 5. So which would be cos of x square plus 5 into derivative of x square is 2x plus 0. It would be 2x cos of x square plus 5. This would be the derivative of 2x times cos of x square plus 5. Okay, this is the first question. Hope you are clear with this. You can just go through this for a few seconds. Okay, now see the second question. What is the second question? I need to find the derivative of cos of sin x. Derivative of cos of sin x. Second question is find the derivative of cos of sin x. What is the derivative of cos x? Minus sine of sin x into what is it? Into derivative of sin x. Very good. So sin x derivative would be cos x. So the answer would be minus sine of sin x into derivative of sin x is cos x. So this would be the derivative of cos of sin x. Let me see the third question. Third question is sine of ax plus b. Find derivative of sine of ax plus b is the third question. Good. What is the derivative of sine? Cos ax plus b into derivative of ax plus b. So this becomes cos of ax plus b into derivative of ax plus b would be derivative of ax plus derivative of b. b is a constant, so its derivative becomes 0. Cos ax plus b into derivative of ax would be a plus 0. So this would become a cos ax plus b. Okay. Now see the fourth question. Find the derivative of secant of tan of root x. Find the derivative of secant of tan of root x. Fourth question. Find the derivative of secant of tan of root x. Good. What is the derivative of secant x? Secant x into tan x. Secant root tan x into tan of tan root x into derivative of tan of root x. So this becomes secant tan root x into tan times root x. What is the derivative of tan root x? Secant square root x into derivative of root x. So it is secant times tan root x into tan times root x into secant square root x. Derivative of root x is 2 root x. So this would be the answer for derivative of secant of tan root x. Just go through this. If you can go through my videos, previous videos, and you are clear with all the formulas and the concepts which I have stated. So to solve this question is not a major task. It is very easy to solve these questions. Okay, let me solve the next question then. Next question is find derivative of sin of ax plus b by find the derivative of sin of ax plus b by cos of cx plus d. Find the derivative of sin of ax plus b by cos of cx plus d. Good question. Let me go to the next video. So fifth question is find derivative of sin of ax plus b upon cos of cx plus d. So this would be same as derivative of u by v rule, that is cos of ax plus b into derivative of sin of ax plus b minus sin of ax plus b into derivative of cos of ax plus b upon cos square cx plus d. So this is cx plus d. Cos is cx plus d. Sorry. cos ax plus t into derivative of sin of ax plus b minus sin of ax plus b into derivative of cos of cx plus d upon cos square of cx plus d. So this becomes cos of cx plus d into, what is the derivative of sin? Cos ax plus b. And what would be the derivative of into derivative of ax plus b? That would be a minus sin of ax plus b into, what would be the derivative of cos? That would be minus sin cx plus d into derivative of cx plus d. What would be the derivative of cx plus d? Which would be c upon cos square cx plus d. Good. So this becomes a cos cx plus d into cos ax plus b upon cos square. I can simplify it further. As I have cos and cos in the numerator, that is only the thing I am doing. Till here it is up. If you can apply this step, you are almost done. The next things are just simplifications. Minus into minus becomes plus, plus c times sin of cx plus d into sin of ax plus b upon cos square cx plus d. The cos in the numerator, the cos in the denominator get cancelled, so I am left with a cos ax plus b by cos cx plus d. The same thing can be written as a cos ax plus b. 1 by cos is secant cx plus d plus sin cx plus d by cos cx plus d is tan cx plus d. 1 by cos is secant cx plus d into sin of ax plus b into sin of ax plus b. This would be the most simplified form. Even you can leave till this step. It's correct, but I have just written the solution in the most simplified form. You can just go through this most simple. You should know the quotient rule, which I have discussed, which is derivative of u by v. Once you know the quotient rule, you should know what is the derivative of sine function and the derivative of cos function, and you should know what is the meaning of a composite function and derivative of the composite function. Then it is very easy to solve this question. You can go through this question for a second so that I can solve the next question. The next question is, find the derivative of cos x cube into sin square x power 5. Cos x cube into sin square x power 5. Sixth question would be, find derivative of cos x cube into sin square x power 5. So this is a like product rule, u function, v function, product u v rule, two functions. So this would become cos x cube into derivative of sin square x power 5 plus sin square x power 5 into derivative of cos x cube. So cos x cube into derivative of sin square x power 5 would be 2 sin x power 5 into sin derivative is cos x power 5 and x power 5 derivative would be 5x power 4. Sin square x, it is like x square. What is the derivative of x square? 2x. If it is x square, for example. That is the reason I have written sin square x power 5 as 2 times sin x power 5. Here x is. So, and what is x here? Sine function. So, I should do derivative of sin x power 5, which is cos x power 5. It is not cos x power 5. So, I should do the derivative of x power 5 also, which is 5x power 4 into sin square x power 5 into derivative of cos is minus sin x cube into derivative of x cube is 3 times x square. So it would be 2 into 5 is 10 x power 4 sin x power 5 cos x cube into, I am doing nothing, I am just rearranging the terms in the given term, just rearranging the each and every term given expression. Plus into minus becomes minus 3x square sin x cube into sin square x power 5. This should be the derivative of cos x cube into sin square x power 5. We can go through this for a few seconds so that I can solve the next question. Seventh question is, find the derivative of 2 times root of cot of x square. Find the derivative of 2 times root of cot of x square. Find the derivative of 2 times root of cot of x square. Good. So this derivative would be 2 times derivative of root of cot x square. What is root x derivative? 1 by 2 root x. What would be cot x square derivative? Into derivative of cot of x square, right? Into derivative of cot of x square. What is the derivative of 2 in the numerator and 2 in the denominator? Get cancels. So this is 1 by root of cot x square into derivative of cot x square would be minus cosecant square x minus cosecant square x, but instead of x I do have x square here. So I need to do derivative of into derivative of x square. So derivative of x square, this becomes minus cosecant square x square into derivative of 2x, x square is 2x, by, I can write this as root of, I can simplify it further, nothing, you can just even leave till here, but simplify it. It is always better to simplify any expression to the lowest possible. Let me solve this here in this box, simplification. So this becomes minus 2x upon sin square x square into root of cos x square upon root of sin x square. So sin square x square, it becomes minus 2x by sin x square. I can write into sin square x square as sin x square into sin x square. So out of 1 sin x square root, 1 get cancelled, so I am left with root of sine x square into cos of x square. Multiply with root 2 in the numerator and denominator, because 2 sin x square, 2 sin x cos x is sin 2x. So this becomes minus 2 root 2x upon sin x square, sin x square into sin of 2x square, sin 2x, but instead of x I do have sin x. So this is the most simplified form. Even this is correct. So if I want to simplify it further, this is no calculus in this. This is a trigonometry and basic algebra. If you know the trigonometric and the basic algebra, you can simplify it to the lowest terms that is possible. This will be the lowest term that is possible. Even this should be one of the options. Hope you are clear with this question. Let me solve the next question. You can go through this question for a second. So once you are clear with this, we shall solve the next question, that is derivative of cos of root x. Find the derivative of cos of root x. What is the derivative of cos of root x? Minus sine of root x into derivative of root x. What is the derivative of root x? 1 by 2 root x. So this becomes minus sine root x into derivative of root x is 1 by 2 root x. So this becomes minus sine root x upon 2 times root x. The solution for derivative of cos of root x. Be clear with the formulas and the basics which I have taught in my earlier videos. Again I am repeating this because if you are clear with that, you can solve any one of these questions. Good, let me solve the next question. Then the next question which he is asking is, prove that the function f given by f of x is equal to mod x minus 1 for x belongs to R is not differentiable at x is equal to 1. Prove that the function f given by f of x is equal to mod x minus 1 where x belongs to R is not differentiable at x is equal to 1. Good. So already I have discussed when I can say that a function is not differentiable when its limit does not exist, means its left hand limit should not be equal to the right hand limit. So let me see what happens to the left hand limit of this function. So let me write the limit of this function. What is the limit of this function? Limit extends to 1 f of x minus f of 1 by x minus 1 should be the limit of this function. Very good. If limit x tends to minus 1, what happens to this f of x? This will become minus of x minus 1, because if x is less than 0, mod x is minus x. Similarly, x minus 1 should be mod of x minus 1. And limit x tends to 1 plus, what would be f of x? It would be x minus 1. Very good. So limit x tends to 1 minus, it would be minus x minus 1 upon f of 1 is 1 minus 1 upon minus, it is minus of x minus 1. F of x is minus of x minus 1 minus f of 1 is 1 minus 1 by x minus 1. So this becomes minus of x minus 1 upon x minus 1, which is equivalent to minus 1. Limit x tends to 1 plus f of x minus f of 1 would be x minus 1 minus 1 minus 1 upon x minus 1. That would be x minus 1. 1 minus 1 would be 0 upon x minus 1. X minus 1 by x minus 1 is 1. So left hand limit of this function is exists and it is finite minus 1. Very good. And the right hand limit of this function is also finite and exists, but they are not equal. So clearly I can say this, the limit does not exist. If the limit does not exist, the function is not differentiable at that particular point. So the given function f of x is equal to mod x minus 1 is not differentiable at x is equal to 1. Concept is so simple. If we can find what is its left hand limit and what is its right hand limit, and if you can see both of them are finite and if they are equal, then definitely the differentiation of this function limit exists, so the differentiation of this function should exist. But unfortunately, left hand limit and right hand limit exist and they are finite and equal, and they are not equal. That is the reason I can say the limit of this function does not exist. Hence, we cannot differentiate this function at x is equal to 1. The differentiation of this function does not exist at x is equal to 1. Hence, ninth question was proved. Okay, we can go through this question for a few seconds. So that I solved the last question, that is the 10th one. Now the last question, that is the 10th. We are done even with the 9th one. Now the 10th. Prove that the greatest integer function. Any idea what is the meaning of greatest integer function? Suppose if we have, I want to find what is the greatest integer function of, generally the greatest integer function is defined by this symbol. I would like to find greatest integer function of 2 point. The output of greatest integer function would be the least integer, the output of this would be 2. Okay, means this is a number which should be less than this number and it should be an integer, and greatest of all the numbers that are less than 2.1. Similarly, if I take 3.9, what would be the greatest integer function of 3.9? It would be 3. If we take minus 1.2, what should be the greatest integer function of minus 1.2? It should be an integer which should be less than this, but greatest of all the numbers that are less than this. That means it is not minus 1, it should be minus 2. Minus 1 is greater than minus 1.2. It should be an integer which is less than this integer, but greatest of all the integers which are less than minus 1.2. So answer is minus 2. Just remember these 3 examples in mind so that you get an idea about this, what is the greatest integer function is. Prove that the greatest integer function defined by f of x is equal to this greatest integer function for 0 less than x less than 3 is not differentiable at x is equal to 1 and x is equal to 2. Good, simple. I do have a greatest integer function. Next and the last question, that is the 10th one. They do have given a greatest integer function which is f of x is equal to greatest integer function. So I need to prove this is not differentiable at x. So limit x tends to 1 minus, what happens to the greatest integer function? Limit x tends to 1 minus means around 0.9999 so on. 0.999 step would be 0. If it is 1.001, what would be 1.001? It would be 1. So limit x tends to minus 1 step x is clearly, so the greatest integer function is 0, and limit x tends to 1 plus the greatest integer function becomes 1. Am I clear? So the left hand limit of this greatest function integer is clearly not equal to the right hand limit. So I can say this, the limit of this function does not exist, hence the limit of this function does not exist. LT means limit. Limit of this function does not exist at x is equal to 1. Since the limit does not exist, clearly the function is not differentiable at x is equal to 1. Now the second part of this question, I need to prove this function is also not differentiable at x is equal to 2. I am 100% sure you can clear with what I have solved in this board for the first part. Happily you can solve the second part. Can you try it on your own? So limit x tends to 2 minus greatest integer function. What would be the value of limit x tends to 2 minus greatest integer function? It would be 1, because 1.99 step x would be 1. Limit x tends to 2 plus the greatest integer function would be something close to 2. So again clearly I can say that left hand limit of this function is not equal to the right hand limit, hence the limit does not exist. If the limit does not exist, the function is not differentiable at x is equal to 2, hence limit does not exist. Limit of this function does not exist at x is equal to 2. Since the limit of this function does not exist at x is equal to 2, I can clearly say that the function is not differentiable at x is equal to 2. Function is not differentiable at x is equal to 2. Already I have proved it is not differentiable at x is equal to 1 in the previous page. Now I have proved that it is not, the limit does not exist. LT means limit. It is function is also not differentiable at x is equal to 1. So clearly from these two pages I can say that the function is not differentiable at x is equal to 1, and it is also not differentiable at x is equal to 2. Okay, so these are some few problems from CBSE and CIT 12th math book which are based on trigonometric functions, composite functions, the power rules, and algebra functions. Algebra functions you should know for each and everything, that addition of two functions, subtraction of two functions, product of two functions, and quotient rule of two functions. I hope you have enjoyed watching this video. Solve these questions again and again so that you will be more comfortable when we go for application of differentiation concepts. Thank you. See you in next video. Have a good day. Bye.